Hello, guys. I hope you all are doing good. So, today here I'm going to make a video on a topic, and that is memory management in Python. We basically know when we were small, the teacher used to tell us that there are basically two types of memory, that is RAM and ROM, random access memory and read only memory. But since we are grown up now, we have to know that there are in-depth to memory, that is stack and heap memory. So what is RAM? So RAM is nothing but it is, if you don't know, it's basically a storage in our computer which holds the value like the variables we declare. So let me show you one picture. You can see here that in the upper part, that is the top of this RAM, we have stack, and in the bottom we have heap. So now you are curious to know that what is stack and what is heap. So if I want to tell you that stack is nothing, it's a memory, and heap is also memory, but main difference lies here. Stack, in stack, the memory is there during the compile time. That means during the compile time, the memory gets allocated. But in case of heap, it is a dynamic memory allocation. That means in case of stack, any memory block has name are created inside the stack. But in case of heap, dynamic memory is allocated where allocation and deallocation are done during the runtime by the programmer. In case of C++ language, we use new and delete, if you can remember or recall it. And in case of C, we use malloc and calloc. And also let me show you another picture, then it will be better clear to all of you. Here, I have just gave a small key differences. You can see that allocation here is in case of stack is automatic, that is during the compile time it's occurred, and in case of heap it's manual, that is during the runtime it occurs. And in if you see structure, then it's LIFO. LIFO means last in first out. That okay, that means it's last in first out structure. And in case of heap, the structure is random access. And if you talk about the speed, then obviously, since it's allocated during the compile time, it's faster. And since heap is allocated during the runtime, memory is allocated during the runtime, therefore it is slower. And if you talk about the memory size, it's smaller, and in case of heap, it is larger. And if you tell about the uses, then stack is used for the local variables, function calls, return address. And in case of heap, if you talk about the uses, then we use it for the large data structure or objects that need to exit beyond the scope of the function. And also, let's talk about the lifetime. It's it's limited to the function block. That means memory is valid during the function, that is the scope of the function. But in case of heap, the lifetime, then memory persists until it is explicitly freed or the program gets terminated. Okay, that's the major differences. Just you remember that in case of stack, memory is allocated during the compile time, and in case of heap, memories get allocated during the runtime. And in stack, what it does, it stores the reference of the object, and the object gets space in the heap memory. Clear? So let's give a small example. So you see, I have wrote a program here. Number I have given 39 and I'm printing the address. Another thing I am doing, I'm incrementing the number with 1 and I'm here also printing the address. So let's run this program. So what it should be, since we are giving 39 to this number variable, and again we are incrementing the value of 39 by 1, and again assigning it to the same number variable. So you can see that the variable is same, that is the number. See here in line number 1 also you can see the name of the variable is number, and in line number 3 also you can see the name of the variable is number. So it should give the same address, right? So let's see, it should be give same address or it should give different address. Let's see it. So you can see in case first it's giving address, and in second also it's printing an address, but both the address are different, so it's not giving the same address. So from here we can tell, though we are giving the same name, that is the same variable, but it's referring to different object. That means 39 is getting stored in different memory space, and 39 plus 1, that is 40, is getting stored in different address. That means in first case, that is in this case, it is referring to different memory address, and where this object is stored, it is stored in the heap memory. And in this case, second case also, though the name of the variable is same, but it referring to the different object, that is 40, which is stored in different address in the memory. So let's see it in a very much in a graphical representation way. See, here you can see in stack, first the number is referring to 39, and in second also it's referring, see, different memory address, that is 40. That is, this object is holding this memory address, and this 40, though the number is referring to the same, that is the number is having the same name, but it is having a different memory address. So when we create a variable number, it has this reference in the stack that lists to our object in the heap. So it has its reference in the stack, and it leads to our object that is in the heap. So in our case, it was 39. So when we declare the number, we define it with a new value. See, we declare a number and we declare it with another new value, where for instance, it has a new address, that is 4352. So when we use this object plus 1 and allocated a new space for the new object, which is 40. So this reference to the object 39 no longer exists. So when the number is now referring to this new object, so it will not refer to the previous object, and the garbage collector will go ahead and deallocate this object from the memory. So I hope you all have understood this concept. What is stack memory, what is heap memory, how the object is stored in heap, and how it's from stack we are referring it in the heap memory. by this address. So it's referring to the object which is stored in the heap memory. So though we are having the same name to the variables, still we are getting the different memory address since they are getting stored in different memory address. Clear? And stack as memory is allocated during the compile time, and in case of heap it is allocated during the runtime. And also in case of stack, any memory block has name or credit inside the stack, and in case of heap it's a dynamic memory allocation. Okay, so bye bye, have a good day, and stay tuned to the next video.